Hello, everybody. Welcome to 3.5, where we talk about displaying quantitative data with histograms. So histograms are like bar graphs, but they are distinctly different. And we'll try to talk about that a little bit throughout this section of notes. But just remember, you're gonna like think of it like it's a bar graph. But again, I want you to understand there are definitely some differences between this and a bar graph. So let's get into this. So first thing is histogram shows each interval. Okay, let's fill that in. Let's zoom in a little bit there. Shows each interval as a bar. The heights of the bars show the frequencies or relative frequencies. So remember, that's like their counts or their percentages. Remember the difference between frequency and relative frequency. Frequency was like their counts, and the relative frequencies was like the percentages of them. Of values in each interval. All right. So we'll talk more about that once we start seeing a histogram. Histograms are most useful with large data sets. Large data sets. Intervals are sometimes called bins, classes, or buckets. So just a couple different names for them that you might run into every once in a while. Okay, so if you look down here, we have one set of data, same data, set in a dot plot and histogram. So here's like the original dot plot for each individual value, like, I don't know, 2.3 or 4.7 or whatever these are, right? But it's a regular dot plot. It says percent foreign born residents, right? So obviously these are percentages. Now, if you made the dot plot, but you broke it into intervals, essentially like saying, here's how many are from 0 to 5. So we're not exactly saying what they specifically are, but that there's this many between 0 and 5. So it's kind of like taking all these from 0 and 5 and just collecting them together and finding a total for that interval, 0 to 5. So that's what an interval is. An interval is like a miniature range, right? So 0 to 5 is an interval, 5 to 10 is an interval, 10 to 15, right? So that's what they're doing here. Is they're taking these, for example, from 5 to 10, and they're just counting how many are between 5 and 10, and they're making them a big stack. So again, in this format, you don't know exactly what each dot is, but you know that each dot was somewhere between 5 and 10. And so they do that for the 10 to 15, 15 to 20, 20 to 25, and 25 to 30. But rather than making it like this, what if we just made them bars? So that's how this comes about. So just make them a bar. So 0 to 5 is a bar that goes up to 14, indicating the 14 dots here, the 14 data values that were between 0 and 5. Then between 5 and 10 seems to be about 18 or 19. So again, that's emphasizing the 18 or 19 dots that are there, and so on, right? So 10 to 15, that's probably about 8 of them, 8 dots. 15 to 20, that's 5 dots. 20 to 25 is the 3, and then 25 to 30 was just the 1 dot. So just makes them a bar graph instead. But it's not a bar graph, it's a histogram. Now, a couple things I'm going to go ahead and mention about the difference between bar graphs and histograms. Bar graphs will have spaces between the bars. Histograms do not. As you can see, these bars are connected, right? There's no space between them. And this is important because it's an interval range. This bar is carried from 0 to 5, and the next bar goes from 5 to 10. So there's no gap in the numbers because it's based off a number line. So if you left a gap there, that would mean that there's a gap in the numbers, that you're like excluding something or leaving something out. So it's important that we don't leave any spaces, because otherwise our intervals aren't full. So it's important that histograms, the bars are connected. The only reason the bars wouldn't be connected is if there was a gap in the interval. So for example, imagine there was no values between 10 and 15. Well, if there's no values between 10 and 15, this bar would be at 0. So it would appear to have a gap. That's the only time a gap is acceptable for a histogram. But bar graphs can have gaps. And the other main difference is bar graphs are typically used for categorical data. You know, like what's your favorite pet? What's your favorite color? What's your favorite movie genre? Those type of things, those categorical values. A histogram would be used more for quantitative things. And that's important because, like I said, it's based on a number line interval. So histograms will always be for quantitative values, numerical values, because its x-axis here should be an interval of numbers. Okay. So histograms, no gaps between the bars, and it's for quantitative data, numerical data. Okay. All right, let's look at our example here. We'll make one. So it says ancient Egyptian embalming techniques and the climate in Egypt can preserve bodies of the dead remarkably well. Researchers made measurements of 30 Egyptian male skulls that date from about 4000 BCE. One variable they recorded was the maximum width of the skull in millimeters, shown in the table. Make a frequency histogram of these data. Use intervals of width 5 millimeters beginning at 115. Okay. So it already kind of gives us an idea of how to structure our data. So it says start at 115 and make intervals of 5 millimeters. So this will go to 120. All right. And next one will go from 120 to 125. Now you're probably asking yourself a good question here, which is what if I have the value of 120? Does it go in this interval or does it go in this interval? Well, it'll go in the second one. So what I'm going to mention about that is these intervals, I'm going to put a little less than sign here. It's not a very good less than sign, but it kind of worked. So this interval is 115 up to 120, essentially 115 to like 119.9. And then 120 would get counted here. This one would go up to like 124.9. But I'm not going to write 124.9. I'm just going to write 125, but with the less than sign to indicate, hey, it goes from 120 up to just before 125. The next interval will go from 125 up to just before 130. The next one will go from 130 up to just under 135. So you see what I'm doing here? You see what I'm saying? That way I know exactly where 130 is going to go. Well, exactly where 135 is going to go. Etc. So 135 up to 140, and then 140 up to 145. And I think that's probably pretty good. So these are the intervals. And then this is going to be the frequencies. So how many did we have between 115 and 120? I have 1. I think it's just that one, so just 1 right there. How many do I have between 120 and 125? So remember, this does not include the 125. That would go in the next interval. So basically 120 to 124 really is what I'm looking for. Here's a 124, and that's the only one. So again, just 1. So the next one goes from 125 to 130. It includes 125, but not 130. So essentially, it's like 125 to 129. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. All right. If we finish counting them out, 130 to 135, there are 12 of these. 135 to 140s, but not including 140, is 7. And then 140 to 145 is 1. So if you keep counting the way that we were doing it, this is what you should get. You guys can double check that. So make sure that I'm right. And then let's go ahead and make our histogram of it. All right. So remember, we're going to have a number line, right? So we're starting at 115 and we're going by fives all the way up to 145. So let's see, 120, 25, 130, 135, 140, 145. Oops. I wrote a 34 for some reason. All right. Oh, a little laggy there, but it's getting there. This was 140 and 145. All right. Nice. All right. And then we'll go our frequency. So we have to go up to at least 12 high. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We'll number these as well. So let's label these axes. So this is going to be frequency on this side. Just go ahead and number or label that frequency. And then down here, this is going to be skull width, right? Skull width in millimeters. So, all right. So our first bar, remember, from 115 to 120 is only going to be one high. So it's basically that tall. 120 to 125 is only going to be one high as well. Remember, these bars are connected. 125 to 130, that's going to go up to 8. So this bar is going to go up to 8. Kind of a big jump there. The next one goes up to 12 from 130 to 135. So this will go all the way up to 12. There you go. Again, you can see how I'm going from 130 to 135 and making that bar up to 12. Then from 135 to 140, we have 7. Right about there, I would say. And then lastly, 140, 145 is only 1 again. So now there's a small bar. So there's your histogram. Again, notice no gaps in the bars, right? The bars are connected. And of course, it's working on that number line because it's quantitative values, numerical values. All right. So now I'll finally describe the distribution. So remember, describe the distribution. This is where you should think of SOX, right? Shape, outlier, center, spread. So shape, start with that. I would say roughly symmetrical. It kind of peaks near the middle-ish here. I know it's you might be tempted to say it's slightly left skewed because we got this one extra like kick right here. And if we didn't have this, it'd be almost perfectly symmetrical. So, but this is only one value, so it doesn't really carry a lot of weight. So I'm gonna almost think it doesn't really have much of an impact on the shape. So I'm not gonna say skewed left unless this was like further down or there's more lower values. But I think roughly symmetrical works. You know, it is a little bit objective, but I'm gonna go with that. Roughly symmetric. Okay. The next one, outliers. So I don't see any outliers here. You know, everything's pretty well connected. There's not like a number at 160. You know, I think if there was something like at 160, randomly compared to all this other stuff, then I would think that that might be an outlier. Or like maybe like 95. You know, 95 is really low. So maybe like if there is one really high or one really low value, but there isn't. So I'm just gonna say no outliers. Center. So the median here. All right. So the median, we're gonna say with we could actually find the correct median if we look back at these numbers here and we try to list them all in order, you know, from the smallest to the biggest, and then we work our way to the middle. But we're gonna use our histogram. So how can I find the median of just looking through the histogram? Well, you're not gonna find an exact number. You're only gonna find out which interval the median is in. So remember that there were 30, right? Yeah, 30 Egyptian male skulls. So the median will be between the 15th and 16th, if you remember how we kind of calculated that before. So the 15th and 16th value are in which interval? So let's count it. So this is the first value, the lowest. This is the second, right? This is 8, so that's 1, 2, 8, which adds up to 10. So these are the 10 lowest. So we're not at the 15th or 16th yet. So, but we have the 10 lowest here. The next one goes to 12. So that means this would be 22 at this point in total. So, right, 1, 2, 10, 22, because you're adding 1, 1, 8, and 12. All right, so this goes from the 10th person to the 22nd person. Then the 15th and 16th value are somewhere in this bar. Does that make sense? Because there were 10 here before. So again, 1, 2, 10, and 22. If you accumulate them, right? 1 plus 1 is 2. 2 plus 8 is 10. And 10 plus 12 is 22. So the 15th and 16th value are somewhere in this region, which is the 130 to 135. So we're going to say the median is between 130 and 135. So we don't know exactly which number it is. We could figure that out if we wanted to go back to these numbers. But because we're using the histogram, we're just going to reference it based on the interval in the histogram. So, cool. And then last one is spread. So our numbers ranged from, this one we can look at, from 119 was our lowest to 141, which was the highest. So 119 millimeters to 141 millimeter range. All right, and that's gonna do it. That's gonna be our histograms. So yeah, if you have any other questions, please let me know. But that'll be it. I'll see you guys in the next one. Bye for now.